Hi everyone, I am R.Bhuvaneshwari, Assistant Professor of Computer Science, A.D.M. College for Women, Autonomous, Nagapattinam. Today my topic computer networks. What is a computer network? A computer network is a collection of computing devices that are connected with each other for the purpose of information and resource sharing among a wide variety of users. Each device in the network is called a node, which is connected to other nodes through wired or wireless media. This is the figure of the connected network. Hardware components. Hardware components, first thing is servers. Server are high configuration computers that manage the resources of the network. The network operating system is typically installed in the server, and so they can give user accesses to the network resources. Server can be of various kinds. For example, file server, database server, print server, etc. Clients. Clients are computers that request and receive service from the server to access and use the network resources. Peers. Peers are computers that provide as well as receive services from other peers in a work group of networks. And next one, transmission media. Transmission media are a channel through which data is transferred from one device to another in a network. Transmission media may be guided media like coaxial cable, fiber optic cable, etc. or may be unguided media like microwave, infrared waves, etc. Connecting devices. Connecting devices act as middleware between networks or computers by binding the network media together. Some of the common connecting devices are routers, bridges, hub, repeaters, gateways, and switches. Software components. Networking operating system. A network operating system is typically installed in the server and facilitate workstation in the network to share files, data types, applications, printers, etc. Protocol show. A protocol is a rule or guideline followed by each computer for data communication. Protocol should is a set of related protocols that are laid down for computer networks. The two popular protocol shoes are, first one is OSI model, that is Open System Interconnection. The next one is TCP/IP model. TCP/IP means Transmission Control Protocol and Internet Protocol. The features of a computer network are more than one feature. First one is sharing. Sharing. Computer networks enable sharing of files, software, hardware resources, and computing capabilities. Speed. The communication speed among the components is fast enough to be compatible with a centralized system. Scalability, that is size. Size of a computer network dynamically increases with time. The network have to be scalable so that they can achieve for future developments. Integration. All the components of the computer network work in a coordinated manner for a seamless user experience. Security. Security means network allows security and access rights to the user for restricted sharing of resources and information. Cost effectiveness. Cost effectiveness meaning networking reduces the deployment cost of hardware and software of a centralized system. Next one is connecting devices. First one, routers. A router is a network device that forwards data packet between computer networks. Routers perform the traffic directing function on the internet. Data sent through the internet, such as web page or email, is in the form of data packets. A router is connected to two or more data lines from different IP networks. That is the model of the router. And next one is bridges. At the same time, modem is short for modulation and demodulation demodulator. It is a hardware component that allows a computer or another device, such as a router or switch, to connect to the internet. It converts or modulates an analog signal from a telephone or cable wire to digital data, that is ones and zeros, that a computer can recognize. And next one, bridges. A bridge is a network device that connects multiple LANs, that is local area network, multiple LANs together to form a larger LAN. The process of aggregating network is called network bridging. A bridge connects the different components so that they appear as part of a single network. That is the model of the bridge connection. Next one is hub. A hub is a physical layer networking device which is used to connect multiple devices in a network. They are generally used to connect computers in a LAN. A hub has many ports in it. A computer which intends to be connected to the network is plugged into one of these ports, for example of the hub. And next one is a repeater. A repeater is an electronic device in a communication channel that increase the power of signal and transmit it, allowing it to travel further. Since it amplifies the signal, it requires a source of electric power. Use of the term has continued in telephony and data communication. This is the repeater, for example. Analog signals is converted to digital signals. Next one is gateways. A computer has the site between different network or applications. The gateway converts information, data, or other communication from one protocol or format to another. A router may perform some of the functions of a gateway. An internet gateway can be transfer communication between an enterprise network and the internet. Gateway of the simple diagram of the gateway. Next one is switches. Switches are key building blocks for any network. They connect multiple devices such as computers, wireless, access points, printers, and servers on the same network within a building or campus. A switch enables connected devices to share information and talk to each other. This is one of the examples of the above. Next one is architecture of the OSI model. OSI stands for Open System Interconnection. It's a reference model. It describes how information from a structured application in one computer moves through a physical medium to the software application in another computer. OSI consists of 7 layers, and each layer performs a particular network function. OSI model was developed by the International Organization Standardization (ISO) in 1984, and it is now considered as an architectural model for the intercomputer communication. OSI model divides the whole task into 7 smaller and manageable tasks. Each layer is assigned to particular task. Each layer is self-contained, so the tasks assigned to each layer can be performed independently. These are OSI model layers, 7 layers. First one, application layer, presentation layer, session layer, transport layer, network layer, data link layer, and the physical layer. Application, presentation, session, and transport layer is a responsibility of the host. Network, data link, physical is responsibility of the network. Characteristics of OSI model. The OSI model is divided into 2 layers. upper layer and lower layer. The upper layer of the OSI model mainly deal with the application related issues and they are implemented only in the software. The application layer is closest to the end user. Both the end user and the application layer interact with the software application. The upper layer refers to the layer just above another layer. The lower layer of the OSI model deal with the data transport issues. The data link layer and the physical layer are implemented in hardware and the software. The physical layer is the lowest layer of the OSI model and is closest to the physical medium. The physical layer is mainly responsible for placing the information on the physical medium. Functions of OSI model. There are the 7 layers of the OSI model: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and then application layer. These are the examples of layers. First one is physical layer. Physical layer transmits the data into bit format. It is a lower layer of the OSI model. It establishes, maintains, and deactivates the physical connection. It specifies the mechanical, electrical, and procedural network interface specifications. Functions of a physical layer. Line configuration. It defines the way how 2 or more devices can be connected physically. Data transmission. It defines the transmission mode, whether it is simple, half duplex or full duplex mode between the 2 devices on the network. Topology. It defines the way how network devices are arranged. Signals. It determines the type of the signal used for transmitting the information. Next one is data link layer. Data link layer. This layer is responsible for the error-free transfer of data frames. It defines the format of the data on the network. It provides a reliable and efficient communication between 2 or more devices. It is mainly responsible for the unique identification of each device that reside on a local network. It consists of 2 sublayers. First one, logical link control layer. It is responsible for transmitting the packet to the network layer of the receive that is receiving. It identifies the address of the network layer protocol from the header. It also provides flow controls. Next one is media access control layer. A media access control layer is a link between the logical link control layer and the network physical layer. It is used for transforming the packet over the network. Functions of the data link layer. Framing. The data link layer translates the physical raw bit stream into packet known as frames. The data link layer adds the header and the trailer to the frame. The header which added to the frame contains the hardware destination and the source address. Physical addressing. The data link layer adds a header to the frame that contains a destination address. The frame is transmitted to the destination address mentioned in the header. Flow control. Flow control is the main functionality of the data link layer. It is the technique through which the constant data rate is maintained on both the sides so that no data generated computed. It ensures that the transmitting station, such as the server with the higher processing speed, does not exceeded the receiving station with lower processing speed. Error control. Error control is achieved by adding a calculate value cyclic redundancy check, that is CRC, that is placed to data link layer trailer, which is added to the message frame before it is sent to the physical layer. If any error seems to occur, then the receiver sends the acknowledgement for the transmission of the computer frames. Access control. When two or more devices are connected to the same communication channel, then the data link layer protocol are used to determine which device has control over the link at the given time. Next one, network layer. It is a layer of three that manage device addressing, track the location of the device on the network. It determines the best path to move data from source to the destination based on the network conditions, the priority of services and other factors. The data link layer is responsible for routing and forwarding the packets. Routers are the layer 3 device. They are specified in the layer and used to provide the routing service within an internetwork. The protocol used to route the network traffic are known as network layer protocol. Example protocols of IP and IPv6. IP means Internet Protocol. Functions of network layer. Internet working. And internet working is the main responsibility of the network layer. It provides a logical connection between different devices. Addressing. A network layer adds the source and destination address to the header of the frame. Addressing is used to identify the device on the internet. Routing. Routing is the major component of the network layer and it determines the best optimal path of the multiple paths from source to the destination. Packets. A network layer receives the packet from the upper layer and converts into packets. This process is known as packetized. It is achieved by Internet Protocol. Next one is transport protocol. The transport layer is a layer 4, ensure that managed or transmitted in the order in which they are sent and where in no duplication of data. The main responsibility of the transport layer is the transfer the data completely. It receives the data from the upper layer and convert them into smaller units is known as segments. This layer can be termed as an end-to-end layer as it provides a point-to-point connection between source and the destination to deliver the data reliability. The two protocols used in this layer. First one is TCP, that is Transmission Control Protocol. It is a standard protocol that allows the system to communicate over the internet. It establishes and maintains a connection between hosts. When data is sent over the TCP connection, then the TCP protocol provides the data into smaller units known as segments. Each segment travels over the internet using multiple routes and they arrive in different orders at the destination. The transmission control protocol records to the packet in the correct order at the receiving end. Next one is User Datagram Protocol, that is UDP. User Datagram Protocol is a transport layer protocol. It is an unreliable transport protocol as, in this case, receive does not send any acknowledgement when the packet is received. The sender does not wait for any acknowledgement. Therefore, this makes a protocol unreliable. Functions of transport layer. Service point addressing. Computers run several programs simultaneously due to this reason. The transmission of data from source to the destination, not only from one computer to another computer, but also from one processor to another processor. The transport layer adds the header and contains the address known as service point address or port address. The responsibility for the network layer is to transmit the data from one computer to another computer, and the responsibility for this transport layer is to transmit the message to the correct process. Segmentation and resemblance. When the transport layer receives the message from the upper layer, it divides the message into multiple segments, and each segment is assigned with the sequence number that is uniquely identify each segment. When the message has arrived at the destination, then the transport layer reassembles the message based on the sequence numbers. Connection control. Transport layer provides two service connection-oriented services and connectionless services. The connectionless services treat each segment as an individual packet, and they all travel in different routes to reach the destination. A connection-oriented service makes a connection with a transport layer at the destination machine before delivering the package. In connection-oriented service, all the packets travel in the single route. Flow control. The transport layer also responsible for flow control, but it is performed end-to-end rather than access a single link. Error control. The error control is transport layer also responsible for error control. Error control is performed end-to-end rather than access the single link. The center transport layer ensures that message reach at the destination without any error. Next one, session layer. It is a layer 3 in the OSI model. The session layer is used to establish, maintain and synchronize the interaction between communicating devices. Functions of session layer. Dialogue control. Session layer acts as a dialogue control that creates a dialogue between two processes, or we can say that is allow the communication between two processes, which can be either half duplex or full duplex. Synchronization. Session layer adds some checkpoint when transmitting the data in a sequence. If some error occurs in the middle of the transmission of data, then the transmission will take place again from the checkpoint. This process is known as synchronization and recovery. Next one, presentation layer. A presentation layer is mainly concerned with the syntax and the semantics of the information exchanged between the two systems. It acts as the data transistor for a network. This layer is a part of the operating system that converts the data from one presentation format to another format. The presentation layer is also known as the syntax layer. Functions of the presentation layer. Translation. The processes in two systems exchange the information in the form of character strings, numbers and so on. Different computers use different encoding methods. The presentation layer handles the interoperability between the different encoding methods. It converts the data from center dependent format into common format and change the common format into receiver dependent format at the receiving end. Encryption. Encryption is needed for maintaining privacy. Encryption is a process of converting the center transmitted information into another from and send the result information over the network. Comparison. Data compression is a process of compressing the data, that is, it reduces the number of bits to the transmitted. Data compression is very important in multimedia such as text, audio and video. Next one, application layer. An application layer serves as a window for user and application process to access network service. It handles issues such as network transparency, resource allocation, etc. An application layer is not an application, but it performs the application layer function. This layer provides the network service to end user. Functions of application layer: file transfer, access and management, FTAM. An application layer allows a user to access the file in a remote computer, to retrieve the file from a computer and to manage the file in a remote computer. Mail services. An application layer provides the facility for email forwarding and storage. Directory services. An application provides the distributed database source and is used to provide the global information about various objects. It is the functions of the OSI model. Next one, the TCP/IP reference model. TCP is Transmission Control Protocol. IP is Internet Protocol. It is used in only 4 layers. First one, application layer, transport layer, internet layer, link layer or network layer. TCP/IP model versus OSI model. OSI reference model is the 7 layers and TCP/IP is used to 4 layers. Introduction to TCP/IP layers. It is used to layers of the protocols. Application layer and presentation layers and the session layers is used to, these are the protocols used in SMTP, FTP, Telnet, DNS and so on. Transport layers is used to the protocols of TCP and UDP. Network is used for the IP. IP means Internet Protocol, data link layer and the physical layers. TCP/IP models. TCP/IP model was developed prior to the OSI model. The TCP/IP model is not exactly similar to the OSI model. The TCP/IP model consists of 5 layers: application layer, transport layer, network layer, data link layer and the physical layer. The first 4 layers provide physical standards: network interface, internet working and transport function that correspond to the first 4 layers of OSI model, and these 4 layers are represented in TCP/IP model by a single layer called an application layer. TCP/IP is a hierarchical protocol made up of interactive modules and each of them provide a specific functionality. Here, hierarchical means that each upper layer protocol is supported by 2 or more lower level protocols. First one is network access layer. A network access layer is the lowest layer in the TCP/IP model. A network layer is the combination of the physical layer and the data link layer defined in the OSI reference model. It defines how the data should be sent physically through the network. This layer is mainly responsible for the transmission of the data between 2 devices on the same network. The function carried out by its layer of encapsulating the IP datagram into frames transmitted by the network and the mapping of IP address into physical address. The protocol used by this layer are Ethernet, token ring, FDDI, frame relay, etc. Next one, internet layer. An internet layer is the second layer of the TCP/IP model. An internet layer is also known as the network layer. The main responsibility of the internet layer is to send the packet from any network and they arrive at the destination of the router they take. Following the protocol used in this layer or IP protocol. IP protocol is used in this layer and is the most significant part of the entire TCP/IP show. Following the responsibility of the protocols. IP addressing. This protocol implements logical host address known as IP address. The IP address are used by the internet and higher layer to identify the device and to provide inter-network routing, host-to-host communication. It determines the path through which the data is to be transmitted. data encapsulation and formatting. An IP protocol accepts the data from the transport layer protocol. An IP protocol ensures that the data is sent and received securely. It encapsulates the data into message known as IP datagram. Fragmentation and reassemble. The limit imposed on the size of the IP datagram by data link layer protocol is known as maximum transmission unit. If the size of IP datagram is greater than the MTU unit, then the IP protocol split the datagram into smaller units so that they can travel over the local network. Fragmentation can be done by the center or intermediate router. At the receiver side, all the fragmentation are reassembled to form an original message. Routing. When IP datagram is sent over the same local network such as LAN, WAN, MAN, it is known as direct delivery. When source and destination are on the direct network, then the IP datagram is sent indirectly. This can be accomplished by routing the IP datagram through various devices such as routers, ARP protocols. ARP stands for Address Resolution Protocol. ARP is a network layer protocol which is used to find the physical address from the IP address. The two terms are mainly associated with the ARP protocols. First one is ARP request and second one is ARP replay. A request, when the sender wants to know the physical address of the device, it broadcasts the ARP request to the network. And then replay. Every device attached to the network will accept the ARP request and process the request, but only recipient recognize the IP address and send back in physical address in the form of ARP replay. The recipient add the physical address both to its cache memory and to the datagram header. Next one is ICMP protocol. ICMP stands for Internet Control Message Protocol. It is a mechanism used by the host or router to send notification regarding datagram problems back to the center. A datagram travels from router to router until it reaches its destination. If a router is unable to route the data because of some unusable conditions such as disabled link, a device is on fire or network congestion, then the ICMP protocol is used to inform the center that the datagram is unreliable. An ICMP protocol mainly uses two terms. The first one is ICMP test. ICMP test is used to test whether the destination is reached or not. Next one is IPMP replay. IPMP replay is used to check whether the destination device is responding or not. The core responsibility of the ICMP protocol is to report the problems, not correct them. The responsibility of the connections lies with the center. ICMP can send the message only to the source, but not to the intermediate routers, because the IP datagram carries the address of the source and destination, but not of the router that is passed to. Next one is transport layer. The transport layer is responsible for the reliability, flow control and the correction of data which is being sent over the network. The two protocols used in the transport layer. First one is UDP and second one is TCP. UDP means User Datagram Protocol. TCP means Transmission Control Protocol. First one is UDP. It provides connection service and end-to-end delivery of transmission. It is an unreliable protocol as it discovers the error but not specify the error. User Datagram Protocol discovers the error and ICMP protocol reports the error to the center that user datagram has been demanded. UDP consists of the following fields: source port address, destination port address, total length, and checksum. Source port address. The source port address is the address of the application program that has created the message. Destination port address. The destination post address is the address of the application program that received the message. Total length. It defines the total number of bytes of the user datagram in bytes. Checksum. The checksum is a 16-bit field used in error reduction. UDP does not specify which packet is lost. UDP contains only checksum. It does not contain any ID or a data segment. Transmission Control Protocol (TCP). It provides a full transport layer service to application. It creates a virtual circuit between sender and the receiver, and it is achieve the duration of the transmission. The TCP is a reliable protocol as it detects the error and retransmits the damaged frames. Therefore, it ensures all the segments must be received and acknowledgement before the transmission is concerned into the completed and the virtual circuit is discarded. All the sending end TCP divides the message into smaller units known as segments, and each segment contains a sequence number which is required for recording the frame to form an original message. All the receiving end TCP collects all the segments and records them based on sequence numbers. Application layer. An application layer is the topmost layer in the TCP/IP model. It is responsible for handling high-level protocols issued for representation. This layer allows the user to interact with the application. When one application layer protocol wants to communicate with another application layer, it forwards its data to the transport layer. There is an occur in the application layer. Every application cannot be placed inside the application layer except those who interact with the communication system. For example, text editor cannot be considered in application layer, while web browser using HTTP protocol to interact with the network, where HTTP protocol is an application layer protocol. This is the protocol used in the application layer: HTTP protocol, SNMP protocol, SMTP protocol. HTTP protocol stands for Hypertext Transfer Protocol. This protocol allows us to access the data over the World Wide Web. It transfers the data in the form of plain text, audio, and video. It is known as Hypertext Transfer Protocol, as it is the effective use in the hypertext environment where there are rapid jumps from one document to another document. SNMP stands for Simple Network Management Protocol. It is a framework used for managing the device on the internet by using the TCP/IP protocol suite. SMTP. SMTP stands for Simple Mail Transfer Protocol. The TCP/IP protocol that supports the email is known as Simple Mail Transfer Protocol. This protocol is used to send the data to another email address. Next one is DNS. DNS stands for Domain Name System. An IP address is used to identify the connection of the host to the internet uniquely, but people prefer to use the name instead of address. Therefore, the system is the name of the address is known as Domain Name System. Telnet. It is an abbreviation for the terminal network. It establishes the connection between the local computer and the remote computer in such way that the local terminal address to be terminal at the remote system. Last one is FTP, stands for File Transfer Protocol. FTP is a standard internet protocol used for transmitting the file from one computer to another computer. Thank you.